start my recording. Okay, so this last night at midnight, you should have turned in the course agreement and 2.1, right? Those were the two things that were due last night at midnight. If for some reason you couldn't find it, I know the first week is kind of, you know, just trying to figure out where everything is, and things are different in different classes and all that. So if you had issues finding out where to go to do your work and all that, just let me know, okay? So I could run through that with you so you can get that done. Okay, so today we are going to start with 2.2. And the first thing we're going to talk about is what makes a relationship a function or not. So on the board, I have written 3 definitions. The definition of a function, and then what the domain means and what the range means. Okay? So when we're talking about a function, that's going to be a relationship that you see on a graph that where each element that's in the domain corresponds to only one element in the range. Once we do a few of these, this definition will make more sense. Okay? The domain are the x values of your function. Or when you're talking about x values, remember the graph has 2 axes. It's got an x-axis and a y-axis. Okay? The x-axis is showing us, the x value shows us how far left and right your graph is going, how much of that x-axis is being covered. The range is your y values, or how high or low the graph goes. Now, the first couple of problems on here is just going to give us a correspondence. It's going to list out domain values and range values and ask us whether or not that would be a function or not. So I'm going to go through the first, looks like 1, 2, 3, 4. 4 are going to be going through this. So on number 1, it's going to give you different values in the domain column and then different values in the range column. The domain column, the values are 10, 6, and 24. The range column, the values are 25 and 21. Then it has arrows going from each of these different numbers that are in the domain to a certain number in the range. For instance, the arrow coming from the 10 goes to the 25. The arrow coming from the 6 goes to the 21. And the arrow coming from the 24 goes to the 25. And it wants to know, is this correspondence a function or not? So what that means, I need to look for, now remember, it's a function if each element in the domain only goes to one element in the range. So let's look at each element in the domain. For instance, the first thing we want to look at is this 10. Where is its arrow going to? 25.
25.
Oh, though, right? It's not going to 2 separate numbers. It's only going to one number. What about this 6? Where is it going to? 21.
21.
Good. That's right. It's only going to one thing. What about
one range?
4? Where is it going to? 25. Again.
25.
Good. Only one thing. There is not anything in the domain that is going to two separate numbers. What? So yes, this is a function. Sometimes it's easier to see what is a function when you see what would not be a function. This is what it would look like if the answer was no, it's not a function. If one of these numbers, any one of them, went to both of those. For instance, if the 24 had an arrow going to 25 and 21, because of this right here, that would have made it not a function, because the 24 was going to two separate elements in the range. That's what would have made it no. Okay? Number 2 is very similar.
Wow.
It's got numbers in your domain, -1, 4, and 8.
Miss Hanson, where are we this morning?
I'm sorry?
What assignment are we on this morning?
Where's what?
What assignment are I logged in because the library wasn't open, so I logged in late. I'm not sure where we are.
Oh, okay. So I'm doing that handout. Okay, here, let me explain this also. So I'm going to start emailing you the handouts. I did it like at 7 o'clock this morning because usually I put them in that weekly folder in Blackboard. However, we can no longer put PDFs in Blackboard. And the reason for that is the I don't even know what they're called, but they go through and they read a document out loud. Yeah, I don't know what exactly it is, but they don't read PDFs very well. Or at all? They don't? Oh. Oh, really? So they don't allow us to put these homework sheets in Blackboard anymore. I have tried to convert this to a Word document. It just totally jumbles it all up. There's stuff all over the place. Okay. If somebody knows how to help me figure out how to do that better, I've tried several different ways to convert it to a Word document, and it doesn't like any of them. I think it's just because of all of the graphs and arrows and things like that, converting from PDF to Word, that just doesn't translate very well. Okay, so I'm going to email these to you. So this handout that I'm going through is actually in your email. It wasn't in there until like 7 o'clock this morning because I didn't realize that this is what was happening until this morning. So what will be in your weekly folder in Blackboard will be this video that I'm making right now for class. That will still be in your weekly folder. So when you go to do your homework and you want to watch the lecture, that's still going to be in your Blackboard. It'll be in your week 2 folder after this class. Okay, but from now on, the handouts that I'm going to work during class will be emailed to you. Okay, until I can figure out how to make them work, transferring them into Word to make them look good. So we're on number 2 on this handout. And if you don't have it printed out, that's fine. I usually write most of the information on the board anyway. Okay, so you're fine if you don't have it printed out. But we're just going to go to number 2 now. Okay, so it says determine whether this correspondence is a function. The elements in the domain are -1, 4, and 8. The only number in the range is a 2. The -1 goes to the 2. Does the -1 go to, how many things does -1 go to? Just one. So it's still a function, right? -1 didn't go to 2 different things. The 4 Also goes to the 2. They go to the same thing, but here's the thing. None of the numbers that are in this domain go to 2 separate numbers. Again, if they did, you would see 2 separate arrows coming out of one of those numbers in the domain. That's what it would look like. Okay? So yes, this one is a function. This was a multiple choice, and so the 2 options say yes. And what they did, if you'll notice, is they switched the words domain and range in those options. So just watch that. So what you want to choose is the one that says yes, because each element in the domain corresponds to only one element in the range.
Right.
Yeah.
Hmm.
Right, number 3 is same kind of thing. My elements in the domain are 64, 125, and 8. My elements in the range are -4, -5, -2. Again, that's what the arrows look like, which means, again, each element in the domain is still only going to one element in the range, right? There's still no arrows coming out of the domain going to separate things. Until we get to number 4. So on number 4, now our domain and range are just cities, and it looks like sports teams. But here, this element, Chicago, goes to Bears, Bulls, and Cubs. So that right there, I don't even need to look, right? I don't even need to look at New York really, because this has already knocked it out of being a function, right? Because where did Chicago go? It went to Bears, Bulls, and Cubs. So it went to more than one element in the range, okay? New York also does the same thing. It goes to 3 separate things. So this is what it would look like when the answer is no, the correspondence is not a function.
I'm so confused.
All right, it looks like 5 through 8, they're going to give us a function, and then they're going to ask us to plug in different numbers into that function. Okay, so like on number 5, it gives us a function. A lot of times when you see a function, it'll say y equals or f of x equals. Sometimes it'll just throw in another letter, like on number 5. It says k of x is how you would read that, equals x plus 7. And then it wants us to find 1, 2, 3, 4 different things that happen to this function depending on what you plug in for x. So the first thing it says is find k of 0. And it'll look like that. What this means is whatever this number is right here, that's what you are going to replace the x with in the function and then do the math afterwards. So if I look at this function, which is x plus 7, and I replace it, replacing the x with 0, still bringing down the plus 7, and then doing that math, which is 0 plus 7, which gives me 7. So again, all you're doing on these types of problems is replacing the x with whatever it tells you to replace the x with. And you're going to do it several times. The next part of this one wants me to replace the x. Still working on the same problem. This is still the same problem. I'm going to replace the x with negative 15. We bring down the plus 7 and then do the math straight across. Negative 15 plus 7 gives me negative 8. If you still are not a fan of adding and subtracting, multiplying and dividing with positives and negatives numbers, just plug that in your calculator, right? Your calculator will do that for you. For those of you, I did have somebody in another class, and I forgot about this. So if you don't have the calculator yet, again, it's very handy because it's very user friendly. There is an app.
What the heck?
App. If you don't want to purchase the calculator, it's not as user friendly because it's on your phone, but there is an app that makes the calculator on your phone. Okay, it's not as user friendly as having the separate calculator. Okay, but it will save you some money if you don't want to purchase it. It's called Calculator X is what it's called. And I think there's several of them. I think there's several different apps that do the TI-84. Okay, now same problem, k of negative 4. So same thing, replacing this x with negative 4 now. So I have negative 4 plus 7, which gives you 3.
3. Right.
Good. For those of you that are doing virtual right now, I'm trying to work around that glare right here. It's real dark in this classroom, so I have to have the fluorescent lights on. But most days I can leave them off and just use the blinds, and there's plenty of light in here, and I don't have to work around this glare. Okay, k of 15. So I have plug in 15 plus 7 and do the math, which gives me 22. And the last part of this one says k of x plus 18. So this one's a little different, right? But just get used to whatever is in here, whatever it is, if it's an apple, if it's a picture of a house, if it's an X, if it's a Y, whatever is in there is what you replace the X in the function with. It doesn't matter what it is. This says whatever is inside these parentheses, put that in place of that X. So instead of X, I write exactly this. So instead of X, I write X plus 18. Then I still have the plus
7.
And then still do math, which means I still have math I can do here, right? This 18 and 7 can combine. Those are like terms. I can't do anything with the x besides just bring it over. It's still there. So I just bring it over, but I do put the 18 and 7 to get together. What does that give me? Plus, what is that, 25? Good.
And then
Go ahead. Did somebody have a question? I thought I heard somebody. I need to open up my chat. Oh, gosh. Sorry, I didn't know.
I'm just saying, is that the end of the problem?
That's
X
the end
plus
of, that's
six.
the end of that
I mean,
problem.
X
When
plus
you do it in
25.
Math Lab, it's going to give you one of those at a time. Like it'll ask you to do K of 0, you'll enter 7 as your answer.
Yes,
Hit check answer, and then it'll say, okay, now do K of negative 15. It's just going to give them to you one at a time like that.
yes, ma'am. So far, so good.
Okay, good. Good.
Miss Hanson, I have no idea what we're doing. I am so lost.
What do you have?
Just follow along.
I don't even see this on my math lab.
Huh?
She emailed it to you.
I emailed it to you this morning. Usually it's in the folder, but they don't let us put PDFs in Blackboard anymore, so I just emailed it to you. So I'm just going through the different problems that you're going to see when you go in and do your homework later today.
Right.
Okay.
I'm doing 2.2 today?
Huh?
Or no?
2.2 is what we're doing. Yeah, just 2.2.
Then why do my 2.2 in the lab look?
So so I'm about to do number 6 on this handout.
Number 6.
Now, what
Okay.
I'm going to do on my number 6 is going to be not exactly what your number 6 is, but it's going to be the same steps. You're just going to have different numbers.
Right.
So what a lot of people will do is just watch the video or do this live and then go back and then just use those notes to help them do their homework. Does that make sense?
That's what I'm hoping. Why I watch it.
Okay.
Why I watch you
So,
teach me.
okay.
No,
So my
it
number
don't.
6 says H of W equals 9W plus 9.
I can't see the writing.
There you go. So when you go in and do yours, your problem's going to be very similar. It's just that your function's not going to be 9W plus 9. It may be 8W
Okay.
4. It's just going to be a different problem that uses the same steps to solve it.
I understand.
Okay.
9W. Is that a plus 9W plus 9?
It is.
Okay.
So my first thing says to find H of 1. What does that mean to do? That means I'm going to go to this function. Here's where you're replacing, always. Right? You're going to replace that W every time with whatever it's telling you to replace it with. This first one tells me to replace it with a 1.
Right.
So that's what I'm going to do. I'm going to put a 1 in place of that W. So I'm going to have 9. What's the mathematical operation here if these two things are touching? What am I going to do here? Multiply.
Multiply.
9 times 1, bring down the plus 9, and then do that math.
I don't even have a
9 plus 9 equals
So 9
18.
times 1 gives me 9.
It's 9.
Plus 9.
Plus 9 is 18.
Good.
Good.
So it's kind of like there's three or four problems in one. Each of these. Because now we're doing the same thing, but we're replacing, this says to find H of negative 8. So I'm still replacing the W.
Now. Bye-bye.
With negative 8. So 9 times negative 8 plus 9. And then do that math again. Let's see, do the multiplication first. 9 times negative 8 gives me negative 72. Drop down my plus 9. And then again, if that, you don't want to be able to do this new math and then math with this math, right? So if that's not your thing, just punch that in your calculator. Negative 72 plus 9 gives you what? Negative 60?
Negative 60. Yes.
And then the last one of this particular problem is find h of 6.7.
Okay. Oh.
I don't know what the heck going on.
So this one, I would probably definitely use my calculator, right? I like how to do multiplying decimals in my head or on paper. Okay, we're past all that. So I'm replacing the W with 6.7. So I have 9 times 6.7 plus 9. Did somebody, what is 9 times 6.7? 60.3. Bring down my plus 9. And add that. So 69.3.
Got it.
Yep. All right, number 7. Number 7 throws us a little curveball. The function for number 7. Is f of x equals, those little bars are called absolute value. So that, the way you read that is the absolute value of x minus 2. You're okay, come on in. This is like number 7, that's right. So the first thing I'm going to find is f of 2. Which means, what is that telling me to do? Replace the x with that 2. So if I do that, I'll have the absolute value of 2 minus 2. Now, what does the absolute value mean? That means how many spaces away from 0 are you? Okay, so that means when you have something in the absolute value, whatever number that is, when it comes out, it's going to be positive. Right? Because even if you have absolute value of negative 15, negative 15 is 15 spaces away from 0. It's to the left of it on the number line, but it's still 15 spaces away. Okay, so that's what absolute value means, is how many spaces away from 0 are you? So the absolute value of 2 is 2.
2.
Right. Bring down this minus 2 to get 0. Same thing. Finding
Is that a 5?
4. F of 4, sorry.
F. Oh, that's an F.
F, yeah.
F
of 4.
Okay.
So I'm going to replace the x in this absolute value symbol with that 4.
4.
Do that. Have the absolute value of 4 minus 2.
It's 4.
What is the absolute value of 4? It's 4.
4.
Right? It's 4 spaces away from 0. So 4.
Right.
But I drop down this minus 2 out here and then do that math. 2.
And that's 2.
Right. Now, here is the curveball. At the last part of this one, we're going to find f of a plus 2.
F.
So when I go to my absolute value bar, open it up, what am I going to put in place of that x? A plus 2.
A plus 2.
Anything that's in here. A plus 2.
A plus 2.
Bring down the minus 2. Here's the thing. Since I don't know what this A is, I can't really simplify what's in there. If it was just a number, I would bring it out and say, this is that many spaces away from 0.
Exactly.
There's a letter in there. I can't simplify that at all because I have no idea what A is. So this right here is actually simply your answer. I can't simplify this any more than it is. So that is exactly what your answer is. And that is because of that unknown A that's in that absolute value symbol. I can't say for sure what the absolute value of this is.
Now you put the absolute value sign in the answer.
That's right. That's right. The absolute value sign does go in the answer. Okay? And again, it's because I cannot say what this is.
How many spaces A is?
It all depends on what that A is what the absolute value of what that would be. But I have no idea what it is. So that's why there's
Yes, ma'am.
simplifying that can happen right here. So that's why it just stays the same.
Okay.
Okay, then the last one
Okay.
like this is number 8.
Number 8.
Moving along, huh? All right, this time our function is f of x equals x to the 3rd power.
Uh-oh. F of x to the 3rd power.
What does that mean when you raise something to the 3rd power? You're going to multiply it times itself 3 times. So whatever number I am plugging in for x, to get the solution to that part of the problem, I'm just going to multiply that number together 3 times. So the first thing says find f of 0. So replace the x with a 0. Raise it to the 3rd power. What do you get when you multiply 0 times 0 times 0? Still 0.
0.
That's right. Next part says f of negative 1.
F of negative 1.
Which
Negative
means
1.
everything I'm doing on this problem,
Okay.
replace the number, just plug it in, multiply it times itself 3 times. So
It's going to be negative 1
1 times negative 1 gives you
times negative 1.
negative 1, right?
Right.
If you want to do in your calculator, go for it.
You got to do that with a calculator.
F of 3 this time, which means I'm going to
That's
do
a-
3 to the 3rd power, not 3 times 3. That's the
3 times 3.
mistake. People just want to multiply those 2 numbers together. That is not what's happening here. That means 3 times 3 times 3, which gives
Times 3. 27. What's that, 10?
to f of 10, it is. Which means,
Okay.
what am I going to do? 10 to the 3rd
Third.
power, which means 10 times 10
Times 10 is
times
100
10
times
again.
1,000.
1,000. I can't do math. That's why you got that calculator.
We know that in our head. This is a long problem.
F of negative 2, which means negative 2 times negative 2 times negative 2 is how you would do negative 2 to the 3rd, which would give you what?
4 times 2, 8.
Negative 8, good. problem, f of negative 3a. So negative 3a
Oh, Lord.
to the third power. I'm going to write this one out. So let's see, what would that mean to do? That means negative 3a times negative 3a times negative 3a, right? That's what negative 3a to the third means, is to multiply negative 3a times itself 3 times. So let's do the number part of this. Let's see, negative 3 times negative 3 is positive 9. Positive 9 times negative 3 gives me negative 27.
Negative 27a.
What about those a's? What is a times a
We don't know.
times a? A to the third power. So negative 27 is what you get from doing the negative 3's. Then you have a times a, which is a to the third. So negative 27a to the third
It's the answer.
is the answer.
Okay.
All right, number 9. So this is a real world problem, I guess, is what you would call it. It says for the function f, described by f of c equals, oops,
Yeah. Couldn't see it.
9
Okay. F.
fifths c plus 32 gives the Fahrenheit temperature corresponding to the Celsius temperature. So what this is so if I know what the Celsius temperature is, I can find the Fahrenheit, because Celsius is what the C is going to be. So it's telling me to find the Fahrenheit temperature when it's 25 degrees Celsius.
So 25.
So in other words, I'm doing exactly what I was doing on these previous 4 problems. I'm going to find, what am I going to replace the C with? 25.
25.
Essentially finding that F of 25. So I go to my function and replace the C with 25, which means I have 9 fifths
9 fifths.
times
25.
5 plus 32. Now, there's a couple of different ways that you can make your calculator do multiplying fractions and adding fractions with the unlike denominator. It's just a preference on which way you like best. I like to just type in this right here straight on my home screen. 9 fifths, open parentheses, exactly what I have on the board, which would be 9 over 5. So 9, to make the fraction bar, you hit the division symbol. So 9 over 5. Then the next thing I have is an open parentheses, 25, close parentheses. I'm going to type it in exactly like that. Here's your parenthesis. Your open parenthesis is right over your 8.
Yes.
So open parentheses, 25, then close them. That's telling your calculator to multiply that 9 fifths times 25. What's after that? Plus 32. I'm going to tell my calculator to do all of it at once. So plus 32. So exactly what I see on the board. Now, here's the issue. When I hit enter, it's going, oh, it gave me actual. So sometimes it gives you a fraction. Okay, this one we looked out and it didn't. What happens when you multiply 9 fifths times 25 and then add 32 to it? What do you get? You get 77. So when it's 25 degrees Celsius outside, that means what we are accustomed to, that means it would feel like 77. So now we're going to use all of this plugging in information that we have. And I'm going to show you a couple, we're going to definitely make the purchase of this calculator worth it on these next kind of problems. Okay, so this is like number 10. F of x, it says graph the function f of x equals negative 2x plus 2. Then it gives me a chart. In my chart, it's got an x column and it says the x's are negative 2, 0, and 2. The other part of this is what is f of x. So it wants you to fill these in. This is nothing different than the problems that what we've been doing. So this says, what is this when I replace the x with negative 2? So nothing different than what we've been doing. So I'm going to replace that x with this negative 2 and see what happens. So let's see, I'll have negative 2 times, what am I putting in place the x? Negative 2. Bring down the plus 2, then do that math. Negative 2 times negative 2 is positive 4. Plus 2 gives me 6.
6.
So when x is negative 2 and I plug it in, what does it give me? What's the answer?
A 6. A 6.
Just the number that goes with that negative 2. What this is doing is creating different points on the graph of this function. Then I do it again. This time I'm going to replace that x with a 0 and see what happens. So I'll have same function, negative 2 times 0 plus 2.
And that'll be 2.
Right, because negative 2 times 0 gives you 0. Drop down the plus 2 to get 2.
What?
What am I replacing the x with? 2.
I'm not tripping with you.
Right here. Okay, make sure to mute
Okay,
yourself.
wait, I'm in the class on
Make sure to
Zoom.
mute yourself if you have
Yeah.
background noise.
1 minute.
So what am I going to replace the x with this last time? 2.
2.
So all I'm doing is changing this number right here, right? That's where the x is. That's all I'm doing each time. So let's see. Negative 2 times 2 is negative 4. Drop down my plus 2, which gives me what? Negative
2.
Then you're going to go to Math Lab. When you go into Math Lab, you're going to graph that, which is what we did a lot of in 2.1 was graphing, right? Plotting those points. Remember how I taught you how to use that yellow rectangle in the top? To see your coordinates so that you're not, remember, because sometimes these graphs are teeny tiny. It's hard to tell where your cursor is, things like that. Okay, so if you need some more help, make sure you go back to the end or to the 2.1 video.
Yeah.
Refresh yourself on.
I'm doing a lot of algebra, Lord have mercy.
On graphing those points. Okay, so that's what you're going to do. Now, here's the thing. Get out your calculator. Whatever your function is, this negative 2x plus 2, go to your y equals button, which is the top left button.
I can learn how to use this calculator yet, though.
Oh,
okay. They gonna be mad at me. My clothes go get
So y equals, oh, I got stuff in my y equals. Do you have anything
I
in
heard
y
that.
equals? Clear it out.
And it's called survival.
All right. I see. Thank you.
All right,
Okay.
make sure to mute. How do I do that? So I'm going to plug this in as that function. Negative 2x plus 2 is what I'm going to put right here. Now remember, your negative button is the button below the 3. It's different than the minus. So negative 2. Now remember where your x button is. Here's your x button. It has like an X and a T. It's right next to your alpha button. And then plus 2. Now go ahead and hit the graph button because you are going to graph that in Math Lab. So you kind of want to eyeball it. First of all, remember you have to tell the Math Lab what kind of shape you're going to draw first before you can plot any points. You have to tell it that you're drawing a line in this case. So now, here's what I can do. Remember what took so long on this problem is just keep plugging in different numbers over and over. Well, what is it doing? It's making this, what is this? This table? Well, look, you have a table function on that calculator. It's the same button as the graph button, but you just hit the second key first. So this right here. So now,
Where are you?
I'll come back. I'm going to look at that in just a second. Okay, so remember this table function, if I can find something that just gives me this part of it, then I don't have to do all that math. So if I hit my second button and then hit the graph button again, because that's what's going to give me this table. So remember, that's what part of this problem is asking me to do, is fill out this part of that table. Well, this does that, right? So I just need to come in here now. Look what goes when the x is negative 2. What is the y that went with it? 6. It shows you that in this table. Now go down,
Yes.
x is 0. What is the y that went
And
with it?
the y is 2.
Right. Now, what's the next thing that it wants me to find when x is 2?
Negative 2.
Negative 2. So it does all of the math that we did right here. That will do that for you. There is no reason to constantly just keep replacing that x when you can use that table feature. Okay. We only have time to do one more. We'll finish this on Wednesday. I'm just going to plug this, the last one, number 11. I'm going to show you, I'm not going to do all this mess. I'm going to do it in my calculator.
Oh, my calculator is so messed up.
Just clear it all out. Just hit the clear button a whole bunch of times.
That's what I'm trying to do.
Now you're not in y equals, are you? But sometimes if you go hit this second button and then hit the button right next to it, that means you just want to quit everything. Second, quit. That should bring you back, and then that should bring you back to just this home screen where you just see nothing. If you see anything here, hit clear.
Okay, mine still nothing.
Good.
Good deal.
So this last problem that we're going to do real quick, f of x equals 3 minus the absolute value of x. Now remember, and it gives me my chart. This time I have 1, 2, 3, 4, 5 different things I'm supposed to plug in. Negative 2, negative 1, 0, 1, and 2. To be able to complete that chart. I don't have to do all that. I just want my calculator to do it. So now is when you're going to go to your y equals button.
Which is?
The top, very left. It has a little
Got it.
equals on it.
Y equals,
Now, I have stuff in mind, so now is when I want to clear and get it out of there. So you should just see that, right?
yes.
Now, I want to type in 3 minus the absolute value of x. So 3 minus.
3.
Now, here's where you find the absolute value. Hit your math button, which is right below your alpha. It just says MATH on it.
Okay.
Hit that. Now, go to the right one. You want to get over to this NUM.
Where?
You already hit math?
Yes.
Now go hit your right arrow one time to scroll over to that NUM, so it's highlighted. The very first thing
I got it.
NUM is ABS. That's absolute value.
Uh-huh.
So hit enter. Now did
Enter.
some absolute value bars in your Y equals. What are you going to put inside those absolute value bars? This X. Remember, your X button is the one that's XT blah blah blah. And then I'm going to arrow to the right out of it. Let's go ahead and graph it just to see. We'll get you accustomed to what these different things that are happening to X make. Absolute values make V-shaped graphs. This one's upside down, but it's a V. Now, what I need to know is when I want to fill out my table. So what do you do to fill out your table? Second, and then hit graph again, because that's going to give you your table with all those X's. And see what you're doing? You're just finding all these different X's in this table and putting in the Y's that go with them. So let's see, what goes with X being -2? 1. What goes with X being -1? 2. What goes with X being 0? 3. What goes with X being 1? 2. What goes with X being 2? 1. So that will fill out the graph for you. Okay? Now, half of you are have another class at 10. Half of the students enrolled in this class are enrolled in the support section of the class. So what I'm going to do now is just pause this recording. And again, this section is there's not much to this support section for 2.2. It's just going to kind of go over the distributive property and combining like terms. Okay, so again, number 1 is going to look something like this. It's going to say simplify to form an equivalent expression. And it says n minus 3n. All it wants you to do is just realize or recognize that those are what's called like terms, because they're both n's, right? They're the same kind of term, and then put them together, right? If there's not a number that you can see in front of your n, it is automatically one of them. So if I do that subtracting and I put those n's together, because there is absolutely no reason in the world to write 1n minus 3n, when you could just as simply write -2n, because that's how much that is, right? 1 minus 3 is -2. So you're just putting all your n's in one basket. That's all that this support section is trying to get to. Okay, so that's all that number 1 looks like. Number 2, same kind of problem. This time we got B's. Got 18B minus 14B. Minus 10B. So again, I want you to recognize that all of these are B's, which means there's no reason to write those as 3 separate terms when it's just the same exact thing as putting all those B's together in one basket. So you just put them together. You've got 18 minus 14, which is 4, then 4 minus 10, which gives you went to the negative side though, right? So all this, when you put that together, gives you negative 6b's. Again, if you wanted to do the math part in your calculator, I know that my answer is going to be B. That's what I'm putting together. You can type in if you want. What would I need to know? What is 18 minus 14 minus 10? We'll just type that in. 18 minus 14 minus 10 on your blank home screen. And hit enter. Right? So there's your negative 6. Okay? Are you with me? So now, when you're still in the graph, you just tell it to quit. So do second. Quit. That always gets you right back to the home screen right there. Okay? Number 3. This wants you to remember how to do the distributive property. So you have a negative in front of your parentheses, and then open parentheses, x minus 5. Now, what the distributive property says is you have a set of parentheses, and there's something bumping up against those parentheses. The way you simplify that is you're going to do what's called distribute, whatever this is, to everything in those parentheses. And when I say distribute, that means you're going to multiply. What does this negative mean? That means that is a negative 1. So I'm multiplying everything inside those parentheses, which is actually going to remove the parentheses, by that negative 1. When you multiply something by negative 1, all that occurs is the sign of it is going to change. So if I have a negative 1 times x, that's just going to turn that into a negative x. So then what do I have? I've got this negative 1 times negative 5. What does a negative 1 do when you multiply it? It just changes your sign. All right, number 4. There's only 8 of these. So you get a negative in front of your parentheses. Then open parentheses, you've got 30C plus 91D. Plus 67. Okay, again, this is just very random, but again, it's just trying to get you used to distributing that negative. So again, we think of this as negative 1. There's 3 terms in here that I'm going to distribute that negative 1 to. So what does a negative 1 do to you? It changes your sign. So let's see, what's it going to make this 30C? It's going to turn it into negative 30C. What's it going to do to a positive 91D? It's going to turn it into negative 91D. And then what's it going to do to this positive 67? Negative 67. Then once I do that, once you do remove parentheses, you do look for like terms, because if there are like terms, you're still going to want to put them together. Okay? There's just no other C's to put with this one. There's no other D's to put with this one. And then there's no other plain numbers to put with that. So there's not any terms I can put together there. But when we get to number 5, I've got 7A minus, and then open parentheses, 2A plus 5, close. So the first thing I'm going to do is distribute what's bumping up to this. This is not the 7A, it's this minus. Just like the last few problems, I'm distributing a negative 1 to those. Now, this 7a just comes down. So what is this minus, or this negative turn this 2a into?
Negative 2a.
So it'll turn that into a negative 2a. It turns that positive 5 into
Negative 5.
negative 5. And this time, I do have like terms I can put together, right? What about these a's? Right? There's no reason to write 7a and minus 2a when you can just as simply write that as there's just 5a. Drop down your minus 5. All right, number 6, 8d minus 5 minus, open parentheses, 5 minus 7d. So, once again, to remove the parentheses, there's a minus bumping up against it, so that's what I'm going to distribute. Those first two terms, I'm just going to drop those down and then use them in a minute when I'm trying to put terms together. So I'm just going to drop down this 8d minus 5. Nothing I can do with that yet. Distribute this negative. So let's see, it's going to turn that 5 into minus 5. What's going to turn this minus 7d into? It's going to change it now to plus 7d. Good, positive 7d. And then combine your like terms. So let's see. Is there other D's to put with this one? Yeah. Right.
So then it's just D.
How many D's do you have? You've got 8.
Oh, sorry, 2, but.
But when you put them together, this is plus 7. So 8 plus 7 gives you how many?
I'm sorry.
15 D's. Now, be careful here. You've got, because I'm going to put these together now too, right? That negative 5 and another negative 5, or a negative 5 minus 5. That's not 0.
10.
Okay, it's negative 10, right? If you wanted to type that in your calculator, you'd hit the negative button first, because what would you want to be telling your calculator? Negative 5 minus 5. If I'm going to type that in my calculator, you would hit this negative button, 5, then minus 5 to give you negative 10. So when I put these are called constants. Numbers that don't have letters on them are called constants, and when I put those together, I get minus 10. All right, number 7, I'll write on the board and then give y'all a second to work it. And then I'll work it. (14x minus 7). Oh, this one's different. Times 3x minus 5 minus 3. I'll walk through this one with you. This is different. So this time it's not a minus 1 bumping up against the parentheses. It's a minus 7, right? Same principle. I'm still going to distribute it. You just drop it down. That's right. I'm going to drop down that 14x. Distribute the negative 7, which means multiply what's inside the parentheses by negative 7.
Oh my God.
Negative 7 times 3x.
This is a mess.
1x.
I don't want this class.
Then what? Negative 7 times negative 5. What kind of 35? A negative times a negative. Good. It changed the sign to positive 35. What do I do with this, you think? Just drop it, right? Just bring it down because it's not in the parentheses. It doesn't get the negative 7. So you just drop it down. Now you put your like terms together. So let's see, let's see, here's an X. Here's an X. Not super confident in my skills with adding, subtracting, positives, negatives. What do I need to tell my calculator? I know it's going to be X. 14 minus 21. What does it give you when you tell it to do 14 minus 21? What do you have good? What do you have negative 7 of? Negative 7 X's. I can also put the 35 and this minus 3 together. Those are also like terms. So just 35 minus 3 gives me what? Positive 32. All right, last one. And this one's filled with everybody's favorite fractions. But guess what? Guess who does fractions for you? Okay.
Do what? What you say? What did you say?
Let's see. Last one. I've got 1/3 times 24x plus 3.
Now.
Minus 1/2 times negative 6x plus 6 plus minus 15. All right, break out your calculators. And go to, just hit, if you're still in graph mode or in y equals, remember all the time to get back to just this plain screen, which is what I want, you hit second and then quit, which is right next to the second button. That's what gets you back to this plain screen, and you want to just clear it out. So what do I do now? I need to use the same stuff that I've been using all along. So the first thing I'm going to be multiplying is 1/3 times 24x. Now, I know it's going to be an x, right? Whatever it is, it's going to be whatever the number ends up being, x. So I just want to tell my calculator to do that 1/3 times 24. Good, good. So if I don't want to do it in my head or do it on paper, I want to do 1/3, which is 1 divided by, gives you that fraction bar, 3. And then just do either times, the actual times symbol, or parentheses 24 close. Either way. So I wanted to do times. Did I do times? Yeah. 24. It's hard to do it. So what did that give me? Gave me 8. So what is 1/3 times 24x? 8x. Then what do I need to do? 1/3 times 3. You can tell your calculator to do that. 1 divided by 3, which is 1/3, times 3. And what did it give you? 1. So now, 1/3 times positive 3 is plus 1. Now, what's bumping up against the second parentheses? Negative 1/2. So now I'm going to distribute that, which means multiply what's inside there by negative 1/2. So remember, so what's the first thing I need to know? Negative 1/2 times negative 6. And then I'm just going to put an X on it, right? Because it's going to be X. Good. It's going to be positive 3, right? Because first of all, it turns positive because you have a negative times a negative. And then that 1/2 times 6. So again, if you're typing it in. So negative. Then 1/2. 1 divided by 2. Times negative 6. That's what gave me that positive 3. So let's see. This right here turns into positive 3x. And then do that last one, -1/2 times +6. -3. Then what happens to this guy? He just drops down. So that -15 wasn't in the parentheses, so it doesn't get the -1/2. It just comes down. Once you distribute to remove the parentheses, you're looking for like terms to put together. So let's do our x's first. Here's an x. And there's an x. So altogether you've got 11x. And then you can put your plain numbers together. And this might be something you just want to do in your calculator, because what do I need to do? I need to do 1 - 3 - 15. What is it? -17. So -17. Okay? So when you do your homework, you'll do the 2.1 support homework, and then right after it is the 2.1 2.2. Are there any questions? And I know it's super confusing because they decided for scheduling purposes to put all college algebra, whether you're college algebra with support or just plain college algebra, they just threw them all together. So it's so confusing. These first couple of weeks are going to just be kind of wacky because, you're coming on Mondays and you're zooming on Wednesdays and you're zooming on Fridays and you're sometimes, it's just all over the place. Half the people stay, half the people go, so it's super confusing. But once we get rolling, it's super confusing for me too. Once we get rolling, it should smooth out of, who does what, who needs to be where, when, and all of that. Okay. So, all right, any questions?
So we do 2.1